Okay, so for the second lecture in ON1, we are going to talk about subsets. So this is where you have a set. You can consider whether another set has all of its elements are contained in the first one, and we have some special notation for that. So let's talk about subsets. So if all the elements of a set A are also elements of a set B, then we say A is a subset of B. And we write it with this notation. So A is a subset of B. So for example, if I just take the elements 1 and 3, that is going to be a subset of the elements 1, 2, 3. But in this case, it's not the case that all of the elements in this one, 1, 2, 3, are elements of this one. So 1, 2, 3 is not a subset of 1, 3. Why? Because the element 2 is here and the element 2 is not there. So you have a little bit of notation for that. Note that two sets are equal if, so let's call these two sets A and B, are equal if A is a subset of B and B is a subset of A. So if you want to check that two sets are equal, perhaps you have them written in two different forms, then you have to check that all of the elements in A, so take a random one, show it's in B, and do it the other way around. And then you will know that they are equal. If A is a subset of B, but they are not equal, so that means that A has some element in it, or B has some element in it that's not in A, right? So A is strictly smaller than B. Then you say that A is a proper subset of B, and say A is a proper subset of B. And we write A, and then you just put this this symbol, but without the thing at the bottom. It's going to say that A is a proper subset of B. Okay. We can take all of the subsets of a set and we can put them all together into another set, and that is called the power set. So the set of all subsets of a set A is called the power set of A, and it's written so we have this another blackboard symbol, it's called P of A. Let us note that the empty set is always a subset. So the empty set, and we have two ways of writing this. We can write it as just this symbol, if we like, or we could write it as the empty set symbol like that. This is always going to be a subset of a set A. Why? Because if I want to check that something is a subset, I have to check that every element in here is also an element in here. But there are no elements in here to check. So trivially, it is a subset. Okay, that's important because when we write down the power set of a set, let's say the power set of the set 1, 2, then we are always going to start by writing down the empty set, because that's always a subset. And then let's look at the other subsets. So I can just take the set containing 1 on its own. I can take the set containing 2 on its own, or I can take the set 1, 2. So that contains all of it, and then I have to close it off. So I start with 2 elements and I end up with 4 subsets. Okay, how many elements? How many elements are in P of A? So this is a nice question to be able to answer. So it uses a little bit of combinatorics. So what I want to do is just to know in a subset whether an element is in it or not. And I can represent these as binary strings. So represent subsets as binary strings. So what does that mean? So I'll just give you an example. If I have 0, 1, 1, 0 for a set of size 4, this is going to mean elements 2 and 3 are in the subset and the other ones are not. Right, so clearly that's going to give me a way of representing all the subsets. So if I've got 4 elements, this one will tell me that elements 2 and 3 are in there. So how many different binary strings can I have? So how many possible binary strings? Well, I have 2 choices for the first number. So that's going to be a 1 or a 0, and if it's a 1, it's in, and if it's a 0, it's out. So in, that will be a 1, or out, which will be a 0. So if there are n elements in A, then I'm going to get strings that are of length n, and I've got 2 choices for the first one, I've got 2 choices for the second, and I go all the way up to 2 choices for the nth one, and there are going to be n of these choices. And so what happens when you do 2 times 2 times 2 up to n times? Well, you get 2 to the n. And that is the total number of subsets.